Not talking. In this one, I'm not playing guitar and talking. I went from the college, blah blah blah, and I studied higher math extensively. I was an engineering major, and went through 3 years. And when I quit because I got an ulcer and it didn't heal till I quit, I thought of three original ideas in math that haven't been thought of before, as far as I know, and I believe them are probably right. And I definitely haven't heard of them from anyone else. So here's the three. Three of them are called. I kind of jokingly call them, but I call it Wiseman's Theorem, Wiseman's Formula, and Wiseman's Identity. So if you're interested, here we go. Especially people that are in school and college. I'm also doing this so that if something happens to me, my ideas don't get lost forever, because these are three original ideas, I think. First, Wiseman's Theorem. Okay, now, geometry is related to numbers, and numbers are related to geometry. Let's start with a square. And I go 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a square. The number is 9. Then I do a Star of David, whatever that, why it's called that, I'm not sure, but it's a 6-pointed star. It starts with a triangle here. 1, 2, 3, 4, and then 3, and then 2, and then 1, and then you make it a Star of David by adding 3 more. And that number is 13, because that's how many dots it takes to make what is a Star of David. Like you can make a Star of David like this, da 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 da, and da 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 da. Whereas this is a square. So you have the number. See that there? I don't know if you can see that very clearly. Oh, you can't, because this is reversed. Well, anyway, this is 9 and 13. You can't see the 9. This is backwards though. Okay. What's funny about this is if you take 9, multiply it. So let's erase that, because now we know where we get where we get the 9 and the 13. So I'm going to start. I have 9 and 13, right? So let's start with 9. 9. I know it's backwards. We're going to multiply it by 3. And then you're going to take 9 also and multiply it by 4. 4. How do you write 4? I'm trying to write it backwards, and I'm goofing up. Okay, 4. Okay. 9 times 3 is 27. 9 times 4 is 36. Then I'm going to take 13, multiply it by 3, and then multiply 13 also by 4. 13 times 3 is 39. 13 times 4 is 52. Oh man, write 52 better than that. Oh God, can't even. 52. Okay, 52. So these numbers we have now. We have 27, and we have 39, and over here we have 36 and 52. So now you see where we get that. Let me erase that now, and now take those 4 numbers. 9 times 3, 27. 9 times 4, 30. 9 times 3, 27. 13 times 3, 39. 9 times 4, 36. 13 times 4, 52. So now we have 27, 39, and then 36 and 52. Let's see what those are, what the significance of that is, and we'll see. So I have the 9 times 3 was 27. The 13 times 3 was 39. Then the 9 times 4 was 36, and the 13 times 4 was 52. So everybody will think about it. We have 27, 39, and 36 and 52. What things are made up of 2 parts with those 2 as subparts? Any ideas? And then add to the total number of the things in that. Well, I'll just tell you. And you can think about it by pausing it or whatever. You don't have to. 27 and 39 is 66. 36 and 52 is 88. 66 is the number of books in the Bible. 27 is the number of books in the New Testament, and 39 is the number of books in the Old Testament. 88 is the number of keys on a piano. 36 is the number of black keys on a piano, and 52 is the number of white keys on a piano. So, for some reason, 9 times 3 and 13 times 3 give the number of books in the New and Old Testaments that add to 66, and which is two numbers to get the same number, of course. And then 9 times 4 and 13 times 4 add to 36 and 52, which make 88, also two numbers together that make the total number of keys on a piano. And then broken down into black keys, white keys, New Testament, Old Testament. That's Wiseman's theorem. Now, that's not really very mathematical, but it's a nice insight into logic and thought. This one's more mathematical. It's Wiseman's formula. The Pythagorean theorem is famous. It just says x squared. I can't write because angle is hard to write from. X squared plus y squared equals r squared for two dimensions, like a two-dimensional right triangle. And it works for x equals 3, gives you 3 squared. Then if y is 4, you get 4 squared. And then that makes r 5, because 3 squared plus 4 squared is 5 squared, which means that if you take a triangle of 3 and one side is 3, one side is 4, and the angles, one of them is the right angle, the largest side will be 5. And of course you can verify that. 3 squared is 9, 4 squared is 16, 5 squared is 25, and of course 9 plus 16 is 25. Big deal. We all learned that in school. But what I thought of after I left mud and had some free time on my hands, why can't you extend that to 3 dimensions? So you can have a 3-dimension, like z's out of the page, x, y, z, the 3 dimensions, not just 2 dimensions, but 3. Well, let's see if it works in 2 dimensions for 3, 4, and 5. Let's see if it works in 3 dimensions for 3, 4, 5, and 6, only you raise the power to the next power, which is cubed instead of squared. So the question is x cubed, or the Pythagorean theorem to 3 dimensions would be x cubed plus y cubed plus z, I can't write z, plus z cubed equals r cubed. And I thought one day to verify, would that work for x equals 3, y equals 4, z equals 5, and r equals 6? Because that would be very remarkable if it did. That would mean a right triangle with another right angle coming out of the page. If one of the sides was 3, then 4, then 5, the length from all the way at the end to the very center would be 6, like a sphere instead of a circle, or a cube instead of a square. Why not? Let's try it and see if it works. No one ever found this out. I'm the first to think of it, I think, and I've never sorted it anywhere else but me, and I'm trying to get it out there. X is 3 would make 3 cubed. Y equals 3 would make 4 cubed. I can even write 4. 4 is hard to write. 4 cubed. Is that 4? Yeah, that's 4 cubed. Plus 5. I can't write 5. 5, that's not even a 5. 5 cubed equals 6 cubed. Question mark. Is that true? That'd be very unique if it were. Like why that would be very highly unlikely without there being a reason behind it. Like not likely if the universe were only coincidental. So 3 cubed is 27. 4 cubed is 64. I'm writing my numbers right. 64. And 5 cubed is 125. I'm writing my 5 backwards. That's backwards 5. There we go. 27 plus 64 plus 125 what does that equal? Do a calculator. Well, it turns out 6 cubed is 216. And sure enough, 27 plus 64 plus 125 is 216. That means if the Pythagorean theorem were extended to 3 dimensions, it would work for x equals 3, y equals 4, z equals 5, and then r would be 6. You can think of it as like a ball of radius, the volume of a ball of radius 3 plus the volume of a ball of radius 4 plus the volume of a ball of radius 5 would be equal to the volume of a ball of radius 6. Just like the area of a square, the area of a circle of radius 3 plus the area of a circle of radius 4 plus the area is equal to the area of a circle of radius 5. That's very interesting, and no one's ever thought of that but me, and I want to get that out there. I think I did the math right here. 27, 64, 125, 216. Quick check. I hope I did that right. 9, 10, 11, 12, 13, 14, 15. Yeah, I think I did. I'll test quickly there to test that right. 7, 24, 9. Yes, I did. Okay, that's called Wiseman's formula. Now for Wiseman's identity. I just did a teasing thing with powers and stuff. Let's say you have 5 sixes. So you have maybe a pentagram, I don't know, with 6 on each corner. What's 6 to the 5th power? That's a 2, not a 5. 6 to the 5th power, I can't even write these things. 6 to the 5th power would be 6 times 6 times 6 times 6 times 6. So 6 to the 5th power, it happens to be equal to 7776, believe it or not. So if you add 1 to it, Wiseman's identity, never heard anybody think of this either, 6 to the 5th power, 6 to the 5th power, that doesn't look like a power though, it looks like a 6, yeah. 6 to the 5th power plus 1 equals 7777. 4 sevens in a row. That's a very cool little identity. So 6 times 6 times 6 times 6 times 6 plus 1 equals 7777. Highly unusual, not very likely to be true if the universe is completely random. Thank you for listening to this video. I don't care about credit for any of these ideas, Wiseman's theorem, Wiseman's formula, or Wiseman's identity, but I do care that I'm not the only one that knows them, and so if something happens to me or whatever, these ideas will be lost in history, or someone else will have to think of them. So have a great, and plus this time I didn't play guitar and I did talk as opposed to playing guitar and not talking. So Paul Gilbert, great guitarist, once said about, in the context he was talking about triplets versus 16th notes, and he says he likes the triplet feel, but anything gets old if you do it long enough. Well, I'm trying to break up the monotony of my channel as I always play guitar. I have one Frisbee video, now I have one math video. So have a great night. I'll talk to you later, and see you soon. Bye. Okay.